Hello and welcome. I'm Jarvis, and in this lesson, we're diving into a powerful feature in SQL Server, User-Defined Functions, or UDFs. We'll explore how you can encapsulate logic to make your code cleaner, more reusable, and more modular. By the end of this 24-minute session, you will be able to create both scalar and inline table-valued functions, understand the critical differences between a UDF and a stored procedure, and, most importantly, recognize the performance implications that every good developer needs to be aware of. So, what exactly is a UDF? Think of it as a reusable piece of code that accepts parameters, performs an action, and returns a result. Unlike a stored procedure, a UDF's primary purpose is to return a value or a table, and they can often be used directly within your select statements, which is incredibly handy. We'll be focusing on the two most common and performant types. First, scalar functions, which return a single value, like a number, a string, or a date. Second, inline table-valued functions, which are fantastic because they return a result set, a table, and are generally very efficient as SQL Server can expand them into the main query plan. Let's start with scalar functions. Their job is simple. One or more inputs go in, one single value comes out. This is perfect for tasks like calculations, data formatting, or simple lookups. The syntax is straightforward. You define the function name, its parameters, what data type it returns, and then the logic inside a begin-end block. All right, let's get practical. For our demo, we'll create a function called fn_getAuthorFullName. It will take an author ID as input and return the author's full name, concatenated as last name, comma, first name. Let's switch over to Management Studio and write this code. Here we are in SSMS. I'll start with the create function statement. The function will be named dbo.fn_getAuthorFullName, and it accepts one integer parameter, @AuthorID. It returns an nvarchar 101 because that's a safe size for our concatenated name. Inside the begin block, I'll declare a variable to hold the full name. Then I'll write a select statement to populate that variable by querying the authors table where the author ID matches our input parameter. Finally, the function returns our variable. Let's execute to create it. Now that our function exists, how do we use it? It's simple. We can use it in a select list, just like any other column. For example, we can select the title of a book and then call our function, passing the author ID from the books table to get the author's name for each book. See how clean that is? The complex logic is hidden away. Next up, inline table-valued functions, or ITVFs. These are my personal favorite because they are both powerful and performant. An ITVF returns a result set from a single select statement. Think of it as a parameterized view. You pass in some values, and it returns a table based on those values. Time for our second exercise. We will create an ITVF called fn_getBooksPublished_after. This function will accept a year as an integer and return a table containing all books published after that year. This is a very common requirement in reporting. Back in Management Studio, the syntax here is a bit different. We write create function, give it our name, and define the @publication_year parameter. Notice the return type is simply table. There's no begin-end block. We just use asReturn followed by our select statement in parentheses. This single select statement is what makes it inline and efficient. Let's create it. Using an ITFV is just like using a table or a view. You call it in the from clause of your query. Here, we can select all columns from our function, passing in the year 2005. And because it acts like a table, we can join it to other tables. Here, we are joining the results of our function to the authors table to get the author's name as well. This is incredibly powerful for simplifying complex queries. A common point of confusion is when to use a function versus a stored procedure. The key difference is intent. Functions are designed to be used within a query to compute and return a value. Stored procedures are designed to execute a series of actions, which can include data modification like inserts or updates and can return multiple result sets. A core rule is you cannot call a stored procedure from within a select statement, but you can call a UDF. Now, for the most important topic of this lesson, performance. While UDFs offer great code reusability, Scalar UDFs, when used improperly, can be devastating to query performance. This is the #1 pitfall developers fall into. Let me explain why. Imagine using our fn_get_author_full_name function in a where clause on a table with millions of books. The SQL Server query optimizer often can't see inside the function. So instead of using an index to find the author, it's forced to execute the function for every single row in the table. This row-by-row execution is known as R-bar, and it prevents any set-based index-seeking optimizations, leading to a massive performance drop. The solution is almost always to avoid the Scalar UDF in the where clause and rewrite the logic directly into the query using a join. In this much better query, we join the books table directly to the authors table and apply the filter there. The optimizer can now see the entire logic, pick the best join strategy, and use indexes on both tables. The performance difference can be orders of magnitude. Quickly, a word on determinism. A deterministic function always returns the same result for the same set of inputs. For example, a function that adds 2 numbers is deterministic. A function that returns the current date and time is non-deterministic. SQL Server is aware of this, and you can specify it when creating a function. Deterministic functions can be used in more places, like in indexed views or computed columns. So, let's recap what we've learned. Scalar UDFs return a single value and are great in a select list, but dangerous in a where clause on large tables. Inline table-valued functions return a result set, act like a parameterized view, and are generally excellent for performance. Always prefer rewriting a query with a join over using a Scalar UDF for filtering. Thank you for joining me in this lesson on user-defined functions. Practice creating both types, and always test the performance of your queries. I'm Jarvis, and I look forward to seeing you in the next lesson.